In today's video, we're going to build a video crop tool using React and the excellent useGesture and React Spring libraries. This tool will let the user enter the URL of the video they would like to edit. Then this video will be presented in this HTML element, and we'll also add controls to pause, rewind, and play the video. But the most interesting part here is this React component that overlays the video and adds this crop button on top. And when the user clicks this button, they'll be presented with this draggable element that they can drag and resize on the screen on top of the video that they entered. And using this element, they'll be able to make a new selection of the video that they would like to crop. Then we'll make an API request that will result in this cropped video based on the selection that the user made. So in this video, you'll learn how to work with video and present it in an HTML element, how to add controls to control the video, and how to add this draggable element that stays within the bounds of the original video and lets the user make a selection by dragging the element on the screen and resizing it. To build this UI, we'll use React, and to build this element, we'll use the useGesture and React Spring libraries. So let's get started by creating a new vid project and then creating this UI using React. The source code for the app that we're building in this video will be available on my GitHub page, which I'll link to below. I recommend that you clone it, run it yourself, and check out the source code. After you clone the repo locally, you can install the dependencies by running npm install, and you can run the project locally by running npm run dev. This is what we're going to start with. I've created a blank vid project using the material UI library and added a few elements on the page. And this is what our code looks like. We have a stack element from the material UI library, and a few elements such as title, the input field for the URL that the user will input, an edit video button, the video container element that will contain our video. Currently it is blank. We have the pause, rewind, and play buttons that are always displayed, and currently they're not active and they don't do anything. And we have this global loading element that we'll take a look at in a second. Currently nothing works yet, all the buttons are inactive and you can click on them and nothing happens. Also, they're always displayed regardless of the state of the app. We also have two state variables. One is the video URL input, which contains a string that we'll use to store the value of the input that the user enters when they choose the video. We also have this isLoading boolean, and this value determines whether our global loader is displayed or not. And this is what the loading component looks like. It's just a backdrop from the material UI library. Let's check out how it looks by switching from false to true. When the value is true, we'll just display this overlay over all of the page, and it will disable everything on the screen and let the user know that they should wait before taking a new action. Let's change it back to false, and it will hide this element. So this is our starting point, and now we can focus on the interesting stuff like the video element and the selection element that allows the user to select the cropped area out of the video. I'm also going to create a CSS file and paste some basic CSS. This is just some styling to make the page look better and nothing related to functionality. And this is how our page looks like after adding the CSS. Let's also add a few state variables. First, we'll add the variable title, which will hold the title of the page. We'll add a video and a set video function. This state variable will just hold the URL of the current video that we're processing. So once the user chooses a video URL input and submits it, then we'll set this value to our video. And finally, we'll create an isPlaying variable, which will be a boolean. And this variable will determine whether our video is currently playing or is it paused. We'll initiate it to true because we want the video to autoplay. And then when the user hits pause, we'll set it to false. We'll use this variable to determine which buttons should we show, the pause button or the play button. We'll also add a callback called onSetVideoURL. So when the user enters the URL and clicks the submit button, then this callback will be called, and we'll use this callback to set the title to crop video, and then also set the video URL to the value that the user entered into the URL input field. Let's update our JSX to use the state variables that we've created. When the video variable is not set, we want to show the input field and the submit button to let the user choose the video they would like to edit. On the other hand, if we do have a video variable, then we don't need the input, and instead we want to show the user the video itself and also the control buttons of the video. If the isPlaying variable is set to true, then we want to only show the pause button. But if the isPlaying variables is set to false, then we want to show the rewind button and the play button. Let's also set the title to our title variable. And when the edit video button is clicked, let's add an onClick event that will call the onSetVideo URL callback. And now let's see how the changes that we made affect our page. Initially, we see the title, enter a video URL, and the text field that asks us for the video URL input. Once we enter some value and click edit video, then we'll see the crop video title. In here, our video element will appear, which we'll add next. And then we have this pause button that if we click it, we want it to control the video. And we also wanted to show the play and rewind button when the video is paused. So let's add that. This is the video element that we're going to add. We want it to loop and we want it to be muted. And we also want it to autoplay. And since isPlaying is set to true by default, we will set autoplay to isPlaying. We also want to limit the width to 300 pixels. And the height will be adjusted automatically. And finally, we want to set the source of this video to the video variable. This will hold the string that contains the URL of the video that we want to crop. Let's also add onClick handlers to our pause, rewind, and play buttons. So we'll add onPause, onRewind, and onPlay, and we'll add a callback for each one of these. In order to control our video element from the callbacks, we'll need to add a reference. So we'll create a new reference. We'll call it vidref. And then we'll add a ref attribute to our video element that will point to this reference. Once we have a reference, we can use it in the callbacks to control the video. So first, in the onPause callback, we want to set the isPlaying state variable to false. And then we want to use the reference to call the pause function. And it's very similar in onPlay. We'll just set isPlaying to true and then call the play function. And in onRewind, we want to pause the video. And then we want to set current time to 0. Now let's try our app again and see if our video controls work as they should. I'm going to use the sample video I have, so I'll copy this URL. And in our app, I'll enter this video as the video that we would like to crop. I'll hit edit video. And now we can see the HTML video element and it's autoplaying, it's muted. And by default, we see the pause button. And if you click the button, the video pauses, and then we have the rewind and play buttons. The rewind button works and also the play button. So now we have the controls that control the video. We're now ready for the main part, which is the crop React component that will overlay the video and will allow us to make a selection of the area that we would like to crop. Let's add the video crop component. So in the components folder, I'll add two new files, video crop tsx and video crop tss. Let's create a blank component called video crop. This component will have two props. Children, this will be the video that we're going to display, and then the onCrop callback. This is the callback that will be called when the user submits their crop selection. Let's also add a few types. The first type is going to be dimensions, which will have a width and a height. And the second type will be coordinate and dimensions, which will have a coordinate point in x and y coordinates, and then also a width and a height. This will be the JSX code returned from our component. We'll have a container element that will be the same size as the video. And then we'll also have overlay controls. And these will be the buttons on the top right of our video. So when our video is in cropping mode, we will display the cancel and confirm buttons. And when we are not in cropping mode, then we'll simply display the scissors button. And when the user will tap the scissor button, then we'll switch to cropping mode and then the user can cancel or confirm. Let's also create a state variable to determine if we're in cropping mode or not. If we're in a isCropping state, then we want to display our cancel and confirm buttons. If we are not cropping, then we want to let the user the option to switch the cropping state. Let's also define callbacks for each one of these buttons. When the onDone callback is called, we want to set isCropping to false. When onCancel is called, we want to set it to false as well. And when onEnter crop mode is called, we want to set it to true. I'm also going to add some CSS for our elements. The overlay control div will have an absolute position and it will be positioned on the top right of the video. Now on our home page, let's import this component and include it in our JSX. And we're going to add it right here, and it is going to wrap the video. We'll also need to add an onCrop callback that for now will be an empty function. Since the video appears in the content of the video crop element, we also need to add it in our element. Also notice that there is an issue here, and it should be when it's not cropping, then we will display the scissors. Now let's check out our app and see how it looks like so far. So now we have this scissors button on the top right, and if we click it, then we switch to the cropping mode. So at this point, we need our selection element to be displayed as well. We're going to add this element next. But for now, we have this cancel and confirm buttons, and when the user taps on the cancel button, then it cancels, and when they click on the confirm button, then it tells us that we need to crop the video. Next, let's add the element that will represent the cropped area. On top of our video, we'll add a div called cropped area, and this will represent the square that the user will be able to drag and resize. Then we'll also add a handle on the bottom right of the square that will let the user resize it. We'll give it a class name resizer. And also let's add some CSS. So our cropped area will have a border. It will have an absolute position. We'll give it a top and a left of 0 and a width and a height of 100 pixels. We'll set the Z index to 100, which will be just below 101, which is the Z index of the overlay controls, because we want the overlay controls to be on top. And we also want to dim the surroundings of the selection square. And for that, we'll use a CSS trick using box shadow. We'll give the box shadow a very high value and set its opacity. And this will dim the surroundings of our cropped area. Our resizer will be in an absolute position. We'll set its bottom and right values. And when the user hovers it, we will set the cursor to resize. This is how our selector looks at the moment. And we have this handle on the bottom right that we can use to resize it. Of course, it doesn't work yet. And the dragging doesn't work as well. A few small details. When we hover over this element, we want to see the dragging cursor. We don't see it yet, so let's adjust that. Also, we want these buttons to hide and display the selector, because when we're not cropping, it shouldn't be displayed, and when we are cropping, it should. So let's hide it when we are not in crop mode. So first, let's fix the cursor, and then let's add another CSS selector for when we want to hide the cropped area. So now we'll add this conditional CSS. When we are in cropping mode, we won't add anything, but if we are not in cropping mode, then we'll add this cropped hidden class. And this class will basically hide our cropped area element. So now when we switch between is cropping and is not cropping, then this element will be displayed. And also we can see that the cursor is now correct. What we want to do next is add the functionality to actually drag this element and resize it. And this is where React Spring and use gesture come in. We're going to use React Spring to position the crop select area on the screen. It will give us an efficient way to set the X, Y coordinates and the width and the height of the element that we're going to drag and drop. So let's import the use Spring hook from React Spring. This hook gets one argument, a function, and it sets the initial values of the X, Y, width, and the height. Then it returns the object with the values that we'll need to set to our div that we're going to animate, and an object name API which we'll use to set the values. The way we're going to use it is, for example, when we enter crop mode, we'll be able to say API set, and then set the values of the select area to the way that we would like. For example, instead of being at the position 0 and 0, let's set it to 20 and 20. But in order for these variables to take effect, we also need to set them to our animated div. So first we'll need to change our div to an animated div. An animated is another element that we import from React Spring. And we're also going to set these arguments as the style. So now that we animated this div, we can use this API like we did in this onEnter crop mode and position this element on the screen. So now you can see that the position of our select element is no longer at 0, 0, but it's at 20, 20. And we can also adjust it to any value and it will move to that position. So now if we drag the element on the screen, we can use this API to position it and it will smoothly animate to the correct position. Let's reset it to our default values. We'll set the X to 0 and the Y to 0 and then the height and the width to 100 each. Let's now support dragging for our select element. And for that, we're going to add the useGesture library, and we're going to import the useDrag hook from useGesture React. This hook returns a bind function. And we need to take this function and attach it to our animated div. In our case, it's the cropped area, the element that the user can drag and resize on the screen. So let's add this bind function to our animated div. And we also get the state variable that has attributes that describe the drag and drop movement of the user. If we'll go to the use gesture documentation, under gesture state attributes, we can see a list of all the attributes that this object has. We're going to focus on offset, the offset since the first gesture, and movement, displacement between offset and last offset. In our use drag hook, let's attach these two variables to the global window. This way, we'll be able to inspect them in Chrome DevTools. Now, if we'll go to the console of our Chrome DevTools, we can click on this eye icon to create a live expression. So let's add window.offset and window.movement. Now, as we drag our element, we can see these values updated in real time. We can see that each one of these values is an array that has two items. In each array, the first item is the x coordinate and the second item is the y coordinate. So now using the offset, it will be very easy for us to add dragging to this element. We'll go to our use drag hook and then use the API object from useSpring to set the x and the y position of the cropping element. And now we can drag the element on the screen. And as we drag it, the callback is being called, and then we set the x and the y position of the element to match the position that the user drags this element to. So now dragging works, however, our element still goes out of bounds. And also we need to add the resize functionality. There is one small problem that we need to fix before that. If we cancel the cropping movement and then resume, the element will be reset to the 0 position. If we try to drag it, it will jump to the latest position from the previous drag movement. So we drag it on the screen, we cancel, and then we resume, and it jumps to the latest position instead of starting from where we wanted to start. And that's because the useSpring hook doesn't know that we reset the x and y values to 0. So we need to somehow let it know that every time it should calculate the offset based on the current position of x and y. So if we set the x and y using our API object from reactSpring, it should take it into consideration. And to do that, we can add an additional configuration object to our useDrag hook, and it accepts a from callback. And in this from callback, we can return the coordinates that we want to treat as the beginning point of every drag movement. And we're going to return the current position of our element by calling the get function on both of the coordinates. So these are the coordinates from the useSpring hook. These are the coordinates that we use to position our element on the screen. And we're going to tell the useDrag hook to take these two coordinates, take their values, and then use these coordinates as the starting position for the offset of each movement. Now, if we cancel the cropping and we resume cropping, then the animation will begin from the current position of the x and y element. In the configuration object, let's also add the bounds attribute. This option will allow us to limit the bounds of the movement of our selection element. On top, we want to set the limit to 0 and the same on the left. It means that the x and y coordinates will not turn negative. They will always stay above 0 for both of these coordinates. So now if we move the element, we cannot go beyond these two lines on top and on the left. But we can still drag it outside on the right and on the bottom. In order to limit this element to the bounds of the video, we need to make sure that, for example, on the x coordinate, the element does not go above this point. So we need to take the width of the entire video and then subtract the width of the element and make sure that our x coordinate doesn't go to the right of this point. And the same on the y coordinate. We need to calculate the height of the entire video and then calculate the height of our element. And as a reminder, it can also be resized in the future, but for now it is set to 100. So we need to subtract 100 from the height and make sure our y coordinate doesn't go below this point. So first we need to know the width and the height of our video element. And to get these dimensions, we're going to add a reference to our container element, because our container element will grow with the size of the video. So let's add a new reference. And then go to our container and set the ref attribute of this element to our new reference. Now in the bounds callback, let's see if we can get the dimension of our video from this container ref. Using the client width and the client height attributes, we can get the width and the height of the container. So now we can also set the bottom and the right attributes of our bounds. So the maximum x value will be the container width, which is the width of the video, minus the width of the selection element. So our x coordinate can never go beyond this point. And the same at the bottom. We take the height of the video and then subtract the height of our selection element. So now we limited the movement of our element to the size of the video. Now let's add the option to resize this element as well. If you learned something from this video, I would really appreciate it if you leave it a like. It would help me out by getting this video in front of more people. And if you'd like to get notified about similar videos to this one, don't forget to subscribe to this channel because more similar videos are coming. How can we determine whether the user intends to drag the element on the screen or resize it? If the position of the cursor overlaps with our square over here, then we'll assume that the user wants to resize. However, if the cursor is on top of the selection element while the user drags, then we'll assume that they want to drag it on the screen. So let's create a reference for this element, and then when the drag motion starts, let's check whether the cursor is on top of this element or not. Let's create a new reference. I'll call it drag element, and we'll use it as a reference to our resizer. This is the small blue square that the user will use to resize the selection. Let's go back to our drag event, and our state object is going to contain an event which will contain the element that is currently being dragged. So let's create a new isResizing variable. If the target of the drag motion equals to our drag element, then we'll assume that the user is resizing. Otherwise, we'll assume that this drag motion is to drag the selection on the screen. We will also need this variable in our bounds callback. And this callback also has the same argument of state. The from option will also need this variable, but in the from option, we get the event as the argument instead of the state. So now we need to adjust our drag callback and our two configuration options from and bounds to work with resizing besides just dragging. Let's start from this option from. So we set this option to determine what is the starting position of our offset. When we were dragging, the offset started from the last X and Y position on the screen. But if we're resizing, the starting position will be this point, so we need to take the height and the width of our selection element. So if we're resizing, the starting position for our offset will be the width and the height of our selection element. Otherwise, it will be the X and the Y starting points. And now let's support resizing in our use drag callback. When we're resizing, we're manipulating the width and the height of our selection element, as opposed to when we're dragging and then we're moving the element on the screen, so we change the X and Y coordinates. That's why we also had to change the starting position of our offset. Because when we're resizing, we're changing the width and the height, so the starting position will be the original width and height. Let's see if it works. We can still drag the element on the screen as before, and now we can also resize it. Now let's fix the bounds, because they also need to be adjusted for resizing. When resizing, the max point on the right will be the container width minus the X coordinate, and on the bottom the Y coordinate. The top and the left will determine the minimum size of our selection element. So let's set it to 50. It means that our selection element cannot go below 50, both on the height and the width. So now our bounds work when we drag the element on the screen, and also when we try to resize it, we cannot go above the screen size. And also, if we try to make the selection as small as possible, we'll be limited to width and height of 50. We're finally ready to implement the onCrop callback of this component. And this is when we'll use these two types. We'll use the dimension type to return the dimensions of the displayed video. And then we'll use coordinate and dimensions to return the size and the position of the cropped element on the screen. So let's adjust our onCrop callback. The callback will have two arguments: displayed video size, which will have a width and a height. This will be the size of the displayed video. And then we also have the selector, which will have the coordinates and the dimensions of the selection crop element. In the onDone callback, we'll call our onCrop callback. The displayed video size will have the size of the video. So we'll just copy the container width and the height. And the selector argument will have the position and the size of the selector. We'll use the styles that are returned to us by useSpring, the x, y, width, and the height, and we'll get their values, and then we'll pass these values to the onCrop function. So let's go to our onCrop implementation when we are calling the video crop component, and let's turn it into a callback. Now when we use our component, and if we confirm our selection, then we should get two arguments. First, we get the width and the height of the displayed video. So the width is 300 as we limited it, and the height is adjustable based on the size of the video to keep the proportions. And then we also got the dimension and the position of our selection element. Let's try it again. In this case, we just won't move it, we'll leave it in the same position, so it should have an x and a y of 0 and the width and the height of 100. And these are the values as expected. We now have the coordinates and the dimensions of the area that the user would like to crop out of the video. And to actually crop the video, we're going to use a project that I'm working on called Video API Kit. You can create a free account and get your API key, and let's check out the documentation. We're going to use two endpoints. The first one is going to create a new asset. We'll provide it with the URL of the video and of course the API key that we'll get after creating an account. It will take this URL and return an asset ID for us. And we can use this asset ID to take actions on our asset. The second endpoint that we're going to use is the crop endpoint. We'll pass it the API key as well, and the asset ID that we created, and we'll also pass the X and Y coordinates that we have from the user selections and the width and the height of the area that the user would like to crop. The response will be a new asset with its own asset ID, which we'll then be able to access and return to the user. Let's create a useEditVideo hook, which will let us make all these requests. In our source folder, I'm going to create a new file called useEditVideo. And in this file, first we'll import Axios. Then we'll create an interface which will represent an asset. An asset represents a file on Video API Kit. So when the user gives us a URL, we'll create an asset from this URL. And then we'll manipulate this asset by calling the crop action on it. And the result will be a new asset. And each asset is represented by the asset ID. I'm also creating a secret constant that will hold the secret from Video API Kit. Since this is a demo only, I'm going to use this secret on the client side. But for production use, you must only use the secret on the server, because the secret cannot be exposed and whoever has access to the secret will be able to make requests to Video API Kit on your behalf. Let's also create an API request function, which will make it easier for us to make requests to the API. As arguments, it will take a method, either get or post, and the data that we're passing to our endpoint. And it will return a generic type for us. Now let's create the hook itself. We'll call it useEditVideo, and it will return two functions, createAsset and crop. CreateAsset simply takes a URL and then makes a request to our endpoint to create an asset, and it will return the asset back to us. The crop function will get an asset ID and then the X and Y coordinates of the area that we would like to crop, and then the width and the height of the same selection area. After a successful crop action, Video API Kit will generate a new asset and will return this asset from this function. Now let's go back to our main homepage and import this hook and then use it in our code. When the user submits the URL, the onSetVideoURL function is called. So let's adjust this function to call Video API Kit and create an asset. Before we make the API request, let's show the loader. So we'll set isLoading to true. Then we'll use the createAsset function and pass it the video URL, and we'll get an asset back. And from this response, we want to save the asset ID, and we also get the width and the height of the real video. So we'll create two new state variables, asset ID and video size. Video size will have the width and the height of the actual video. Because when we display the video, if you remember, we limit the width to 300 and the height is adjusted accordingly based on the proportions. So we don't actually know the real width and the height of the video, but in the response from Video API Kit, we'll get these values. And finally, we'll hide the loader. Let's also adjust the onCrop function. So after the user is ready and they make the selection, we'll be able to actually call the API and pass this selection alongside with the asset ID to Video API Kit. And then we'll get the result back and display it to the user. In onCrop, we'll again show the loader. And in order to call the crop endpoint, we'll now need the X, Y, width and height of the selection of the user. The problem is that the selection the user made was made on top of the resized small video. Our video is limited to be 300 pixels wide. When working with the actual video, we'll need to convert these values of the selector to the actual values. And in order to do that, we're going to use this convert dimensions function. It's going to calculate the ratio of the x and the y coordinates by dividing the width of the real video size by the width of the displayed video size. And we'll do the same for the y-axis. Using these ratio x and ratio y variables, we'll be able to convert our crop selection to the values it would have had if the user was working with the actual size video. In response, we'll get the x, y, width, and the height of the actual values that the user wants to select on the large video. And we're going to pass these values to Video API Kit. So we'll call the convert dimensions function, and we'll pass it the video size, the displayed video size, and the crop selection. In response, we'll get x, y, width, and height, and we'll pass these values to the crop function alongside with the asset ID. In response, we'll also get an asset, and this is the new asset, the cropped video that was generated by Video API Kit. Now we can access this asset using this URL, assets.videoapikit.com/ and the asset ID. Now let's also display this URL, the resulting asset, to the user. Our cropping should work now, so let's try it out in the browser. Let's go to our URL, copy it, and then paste it to the app. Now when the URL is submitted, we also make an API request to Video API Kit to create this URL as an asset. You can see we made this request using our access token, and then we got this response back. In the response, we have the duration of the video when it was created, the extension, the MIME type, the original height and width of the video, and the size. The status of the video is ready, so now we can call the crop action on it. We'll use our cropping tool and position it and resize it. And when we're ready, we'll submit. After our request is completed, we get this URL that contains the result of our cropping. So in the new browser, let's open it and enter this URL. And Video API Kit will protect this URL by default. So we can either access this URL using the bearer token like we did before, or we can take our secret and then leave the username blank and enter our API secret as the password. And this way, Video API Kit will let us access the file. And this is the cropped video that we get as a result based on the selection we made on top of our video. The links to the full GitHub repository with all the code and to all the libraries that we use and to Video API Kit will be available in the description of this video. Please don't forget to leave this video a like if you enjoyed it and to subscribe to this channel to get notifications about new videos that I'm currently working on that are coming soon. Thanks for watching, and I'll see you soon.